All right, we're starting part 1 out of part 3 of review of kinematics. Part 1 will just be dealing with velocity and acceleration. And as we know, velocity is just meters per second, rate at which you go a certain distance over a certain period of time. Acceleration is the rate at which velocity changes over a period of time, so it's meters per second over a second equals meters per second squared. And since we're dividing by seconds, we can see that this is the derivative of this. Pretty simple to take the derivative of a velocity function to get the acceleration function, and it makes sense because acceleration function is just the rate at which the velocity function is changing over a certain period of time. So this is all we really need to know. It's just a fundamental relationship between velocity and acceleration, and that will pretty much determine the rest of the problem. And yeah, with a plus c we get from doing the integral just means with a starting velocity, v naught, which is pretty important to think about. So yeah, part 1. Problem 14, a ball of 2 kilograms is dropped from the top of a building, and it gives us a function of velocity of time, and it gives us v of t equals 5 minus 10t. And question 14 asks for the ball's acceleration at time t equals 1 second. Okay, so we have velocity function. Just to get acceleration, we need to take the derivative of both sides. So v prime of t, which equals a of t, equals 5 is a constant, so it goes away. Negative 10t just becomes negative 10 power rule. And there's nothing else, so a of t just becomes negative 10. And so it seems to be irregardless of time. The acceleration at time equals 1 second would equal negative 10 meters per second squared, which is our answer, choice number A. And this makes sense because acceleration is constant in the y direction because of gravity. It's about negative 10 meters per second squared, and it doesn't change, so it should always be negative 10 meters per second squared. Answer choice A.